Listen, have you looked at the stuff for our final project?
I have. I watched his thing and I thought about it. Um, it's just, to me, it's kind of hard. Some of the stuff, I mean, the things he sent over were kind of, I don't know how we would test those. You know what I mean? Did you get that
Maybe, I don't
too
know.
in an email?
Did he
What?
send something else?
What?
Has he sent over something else in one of his emails that wasn't in iLearn?
Well, he sent, like, in his emails, he had kind of like a list of ideas. Did you see that?
I didn't.
Well, and it was like, I
I'm.
mean, it was like testing blood sugar and how we can do all this. And then there was a, but if you read the assignment itself, it's like uh, colors of M&Ms in a bag and stuff. I think that might be more up my alley, to be honest with you.
Uh-huh. Yeah, I. Uh,
Did you
was it in
read
the week eight
what?
pre?
What?
Was it from the week 8 preview that he gave some suggestions?
Well, if you go to like, where is it? Yeah, like in last week he sent,
Oh, the research scenarios.
right, but none of those make sense for us. You know what I mean? Uh,
Uh, let
I
me
really,
let me open the file. I was a bad student and didn't open it. Oh,
um,
yeah, I'd love to count M&Ms as long as I get to eat them afterwards.
well, and see, I thought that would be a fun one. Like if you go to the actual assignment itself, where is it? And I guess we'll just have to go back and forth. It's kind of set up to one person only writes one time, but I think it's just the two of us. We'll have to go back and forth.
Yeah.
Um,
What? Okay, so interesting.
but if you read like design the study, it's more like um, difference in the price of books at the BYU Idaho bookstore compared to those available online.
Mm-hmm.
Fairly easy to do. I mean, even when you go, I don't know if you buy your books, because I have to buy all my books this way,
Yeah.
but if you go online, it actually has the BYU
The
Idaho bookstore has a thing where it compares it to like online. You know what I mean?
mm-hmm.
So that would be an easy one to do. The other one is are the distribution of colors in plain and peanut M&Ms equal? I thought that was an interesting one.
Mm-hmm. Is what he included in that email, is that I need to go back and watch the week 7 preview, I guess, again. But those seem like more of like review questions rather than
Yeah, that's what I thought too. But
top.
he's saying that they're, let's see, well, maybe they're just review questions for that. I didn't watch the whole video, to be honest with you.
Do you
Uh,
want to know? Do you want to know a secret on YouTube?
okay.
There's an option to where you can speed up the video.
Oh,
So instead of it being 20 minutes, you can speed it up to like 1.5 times the speed, and it'll take like 15, or you can even go up to 2 times the speed.
okay.
So
Well, So, what do we want to do for our topics of study?
Um, I don't know. Um,
I mean, the plain and the peanut M&Ms looks interesting. I don't know how we do brands of paper towels being stronger than each other.
that's kind of hard to measure.
I don't necessarily want to count all the chocolate chips in a bag of Chips Ahoy. Are you looking at the
Yeah,
suggestions?
yeah. I don't know. What if I'm trying to think of some kind of cheap product that has a promise type thing. For instance, I don't know, a simple one I remember from high school was just taking just like M&Ms or Skittles or some kind of candy and just
Yeah.
measuring how many candies were in each bag. I mean, it was simple, but
Yeah. I'm just trying to think, we could do stuff like um, uh, I used to work manufacturing. I worked quality assurance, and
mhm.
we would weigh. We would actually have to do some of this sort of stuff, and like weigh tubes of toothpaste and make sure that it was all within acceptable, one way or the other and stuff like that. And I was thinking, something like that, but then I don't want to end up having to go and buy 30 tubes of toothpaste.
No, I know what you mean.
you know, uh,
Um,
something like that would
so
be good, but
so I do quality control, kind of quality assurance for the university support center, the call center on campus. I wonder if it would be possible for me to um, maybe get some data from there for something. Like, let's say we wanted to look at how many times, or let me think. We could research if on campus students call more than online students.
that would be good if we could get the data. We could say our hypothesis is that they're equal,
Uh huh.
right?
Uh huh.
And the null hypothesis is that they're not equal.
Yeah.
Um, but how are we going to collect the data on that?
Well, that's what my job is. I look at that data. I'm not sure if I'm allowed to use that data outside of work, so I'd have to talk to my supervisor about it. But
Okay. Well, because like I don't know if you watched his thing, but he was like, he goes 90% I send back. He goes as long as we submit on time, he'll be okay. But he says about 90% he sends back
right, yeah, I do remember that.
and has people rewrite their proposals. Uh, so uh, that's an interesting one. But yeah, we'd have to find out how we could get that data. If that's usable. What are some other things we could maybe try? I'm trying to think.
We could compare real estate prices from like, let's say we want to look at real estate between um, I don't know, like California and Florida, just or Rigby and Rexburg, or
Well, you're in Rigby. I'm in Kansas City. We could compare those two, I guess, since it's
Good,
something we
yeah.
have access
I
to.
wouldn't want to do it with Rigby though, because Rigby's housing market isn't so great. I'd want to do Idaho Falls,
Little
but yeah,
Falls.
we could do something like that.
Well, and see, Kansas City, you really have to. I mean, it depends what part of town you're in. You know what I mean?
Uh huh. Yeah, because Kansas City is quite a bit bigger than Idaho Falls, isn't it?
Right. There's more people in Kansas City than the entire state of Idaho. So the metro has about 2 million people in it.
Let's see, how many people are in Salt Lake?
I'm not sure. I think Salt Lake itself. I don't know. I know that the metro is a little bit bigger. Um, we
Here,
could
let me
compare like
check.
Salt Lake. We could compare like Salt Lake and Kansas City or something. I
Mhm.
mean, honestly, on internet we could compare anything. It doesn't necessarily have to be places where we are at.
Right.
We would have access to just about any numbers.
Wikipedia. This is Wikipedia. Maybe I should ask Wolfram Alpha. It says that there's about 1 million people in the metro area, but that was from 2000.
In Salt Lake, or
Like the
is that
metro
Salt?
area
Is
of.
that
Sorry,
is
what?
that that's the metro of Salt Lake?
Yeah, from 2000.
Okay. Uh, well, we could try that. Uh,
Well, because we could just take samples from the data. So, I mean, like, we could use Zillow. It's one of those real estate websites.
yeah.
We could just take, I don't know, maybe a random sample from there.
Okay.
I mean, maybe do 50 from each place. I'm not necessarily sure how to do a random sample there, but we could take that, and then from there we can conduct our hypothesis tests, and yeah.
Okay. Yeah. There's 2.34 million people in Kansas City, according to Wikipedia. Uh, we could compare those two, I guess.
I mean, I don't know. We don't necessarily need to do real estate, but that's kind of it seems like kind of a fun one that I don't know. It's not counting M&Ms.
Yeah. Or, we could do just like a cost of living. We could come up with a list of, say, 8 basic things, and I could price them here, and you could price them there, and then we really don't have to buy, 20 tubes of toothpaste or anything like that. We don't necessarily have to buy anything. We could just make a list and each go to Walmart and try to price it out. You know what I mean?
Mm-hmm.
That could be one thing to do, is just
Test to see if cost of living is different.
yeah,
Interesting.
between, say, Rexburg and Kansas City or something.
Okay. Um, would we need to know the population means for that? No, I don't. Ah, man, I kind of don't think so, but I don't. My mind's already starting to have brain farts from semester.
Okay, so state our research question. What populations are you studying? What are your An alternative hypothesis. Which sampling method will your group use? Describe in specific detail how your group will collect data using the sampling method stated in question. And step 4. Also, what sample sizes are you planning to obtain per population? Why do you think this sampling method described in the questions in steps 4 and 5 will give an accurate representation of your population? Oh.
So if we did do a cost of living type thing, we would probably want, I don't know, because we would want the data to be normal, but we'd have
Right.
to get a large sample size in order for it to be normally distributed.
Okay. But would that mean that, we wouldn't necessarily have to get the cost of milk from 30 different places, but maybe 30 different items? I'm not sure.
Well, see, remember categorical and quantitative?
Yeah.
Because the price of milk is more of a categorical type thing, I feel like. I mean, I might be wrong, but um, you're going to categorize the price of milk as like a subcategory of the cost of living.
Right.
So I don't know. Maybe I'm completely off. Kind of sounds like it.
Well, I don't know. Uh,
We could do a study to see which, um, if different brands of toilet paper towels have the same, like if the difference in length of the paper towels or toilet paper is significantly different,
yeah.
then that would be a lot of toilet paper.
Yes.
So maybe not.
Um, let's see.
What's the price of gas over there now?
It's about 224 on the Kansas side and about 215 on the Missouri side because you have different gas taxes in each state.
Okay, we're like 185, I think.
Uh-huh.
What if we just used the price of gas?
That would work because honestly, I could probably find 30 different places here in Kansas City.
Right, exactly. And I mean, I would have to take from probably Idaho Falls, Rigby, and Rexburg, but I mean, geographically, wouldn't that be about the same size?
Yeah, I think that would work.
And I mean, really, we wouldn't even have to go out and look at each individual gas station. We could just we could just use Gas Buddy. Have you ever used that?
Uh-huh.
We could just get on there and get 30, 40 different gas stations and get their price.
Okay. So, what would our null hypothesis be? That there is no difference in the price of gas between the KC area and the Idaho Falls area?
I think so. That there's no significant difference, and then the alternative, I would say that the alternative hypothesis is that the cost of gas in Kansas City is higher than that of Idaho Falls, or we could just say not equal.
Okay.
I don't know. I don't. really understand necessarily how much of a difference that's going to make, but I mean, I know it's going to make a difference. I just don't understand how.
Okay. So I think that would work. And honestly, there's been times where I looked at the numbers and I thought, yeah, there's quite a difference there, but then statistically there hasn't been. You know what I mean?
Right, exactly.
So we honestly, just looking at it, I might think, yeah, there's quite a bit of difference, but the numbers might not pan out that way.
Yeah, I mean, it would be. I feel like it'd be interesting to test. I mean, and the data is not going to be that difficult to collect, and yeah.
Okay. So who wants to write it up? Do you want me
What
to
is
write
it
it up? Or what?
the for the design the study?
Right. One of
Is
us
that
has to write it up, and then what is it?
and
One of
that's
us writes up the design the study. Then we all have to write up collect the data. Then one of us writes up describe the data. One of us writes up make the inference. One writes up take action, and one does the PowerPoint, and then everyone fills out the group evaluation.
okay. And so design the study is due on Saturday.
Correct.
Okay, let me think. I could do it, but let's see. Yeah, I could do it.
Okay. Yeah, if you want to do that, that would help me out a lot because I have to work this Saturday.
Yeah, not a problem. I all of my the majority of my school stress should be over by Thursday, so
Okay.
should be able to do it.
Okay. So we want to get into the subject then?
Yeah, sure. Let's do that. I'm just gonna take a second to write down our research question.
Okay.
Okay. So preparation assignment and we'll pull up the text as well. Okay, so describing stuff. I didn't look at part 2 at all.
That's fine.
I saw that we had to download a file though.
Yep.
I thought to myself, that's great. And I think I've actually already downloaded it, so I'm just wonder how many times I've downloaded the same files.
Okay. see. To this. Okay. Now I have a question on building this pie chart. Maybe I'm doing it wrong, but I have like an undefined blue section. Do you have that too?
I'm still working on making the pie chart. I go to Legacy Dialogues and Pi. I
Right.
want the summaries for group cases. My variable is rank. Okay. Oh, I do. Just that little tiny sliver?
Yeah. And I don't know what that means or what that is. We have someone in there.
Yeah, it looks like there's one, two, two
Someone
people
not.
that aren't listed.
Okay. Well, I guess that.
Did it right, so that's good.
Okay, so there's somewhere we have missing data, and that's why it gives us that blue one.
Yeah.
Okay. So then that's done.
Is there a way to quickly label the pie chart?
Well, I mean, mine comes up with a like a legend on the side, but I don't see anything that's like labeling inside the pie itself.
Okay, I'm doing
But
something.
they've got there, rank it, label it. So we have to label it. Let me go to the. Oh.
Well, I don't. So I found out how to do it. I don't know if it's the best way to do it, but in SPSS, if you double click on the graph, it'll open up the chart editor,
Okay.
and there is an option. Trying to figure out where it is again. On the On mine, it's on the third bar down. It looks like a little bar graph, and when you hover your mouse over it, it says Show Data Labels.
Okay.
So what I did is I clicked that, and then you can choose what's displayed. And then after you do that, you can click Apply, and then there's crosshairs right next to that. And you click on the crosshairs and click on whichever section you want to have labeled.
Okay. When I click on it, I get chart size, fill and border, and variables. Am I clicking it wrong?
Do you see the button right next to it that said it might say, I don't know, it might not. It should say Show Data Labels or
Uh-huh.
oh, interesting. Why is SPSS so confusing?
Categories, chart size,
Okay, so
variables.
if with your cursor you just click on the main graph,
Okay.
it'll have a yellow ring around it.
Yep.
And then go and click the button that says Show Data Labels. It's just to the right of the crosshairs. Did you get that?
Okay. I do not. Let's see.
I get nothing then.
I said I've got variables, fill and border, depth and angle, chart
Is
size,
but there's not one
category.
that, I guess we could, if you wanted to, we could try and screen share, and I could either I could show you what I'm doing, or you could show me what you're
Yeah,
doing.
let me see what you're doing real quick.
Okay. Full screen. Start screen share. Okay. Can you see it now?
Okay. Oh, yeah.
Okay, so I'm here in my chart editor, and once I click on just the main body of the graph, it has this yellow ring around it, and then right here, I click that, and I'm given this.
See, I've got everything else. Well, let me try one more time. Properties. No.
Or if you go up to the Elements tool, or up to the Elements,
Oh, data label mode.
um, maybe. That's what the crosshairs is, and when you click on something, it can toggle which data is
Okay. So when I
visible.
do that, it gives me numbers. Is that what we need?
Yeah. That's exactly it. A 39, 8, 59, and 75.
Yeah. And theirs has percentages on it. Their answer does.
So with that, after you have the numbers that show up,
Uh-huh.
go up to elements and oh no, I'm not sure actually. So to get the percents, I just clicked on this show data labels,
Okay.
and then I got the properties, and it said I can display the percent. Uh,
Hmm. Okay, data label mode. I got all that,
if
but
you
I
go
can't.
to edit,
Okay.
try going to edit and selecting properties. When you do that, does it give you the option for the data value labels? Or I guess the tab.
Just a variables, fill and border, and chart size. Um, See, and I wonder if we're doing the same thing that happens like when I've tried doing Excel is like like I had like 2013 Excel and they were trying to show me something on like 2011 Excel and I'm wondering if I'm on like a different version than you are because I'm using the schools. Um,
Sorry, Bernie, I only caught half of that.
well, no, I'm wondering if we're on different versions. That's why yours is doing things a little bit different. Because I've noticed, like, in my other math classes, I'd be in like 2013 Excel, and the teacher would be trying to show us how to do
No.
something with like 2011 Excel. So I'm wondering, since I'm using the school one, if I have an older version of SPSS.
I don't know. It's possible, I guess.
Uh,
We could always try and screen share from your computer, or
let,
not.
let me. Okay. Do you see my screen now?
Yeah, I do.
Okay. Like, if I go to Elements, I have the data label mode.
Okay. What about under edit?
Okay. And if I go to Edit,
Oh wow.
okay. See if I go to Edit and hit like Properties, I have chart size, fill and border, and variables. That's it.
Try clicking on one of the slices in the pie chart. Uh, maybe. Is there a way to select the whole chart?
Come on. Do that.
Maybe instead of double clicking, just try single clicking.
Okay, that's got the whole chart selected.
Oh, do you see right next to the crosshairs? There's the oh, it's gone now. But
Oops. Okay.
that button right next to it,
Where?
on the third row down of your toolbars.
Okay. That one?
Yeah.
Show demos. Okay.
Aha, there it is.
Okay. So I want
So
to do
then,
percent.
and you can even put the rank too,
So if I
if
did
you
all
want.
that. Oh, cool. There we go.
Bada bing, bada boom.
Okay. So now I have to do a bar graph of it.
Oh, the bar graph.
So same data, but a bar graph.
Same data, so we go to graphs, legacy dialogues, just bar.
Yep.
Here's my question. What's the difference between a bar graph and a histogram?
There we go.
Teddy bear, you're quiet.
And, yay! Okay. Figured that one out.
Okay. I need to make sure. Is the labeling, does it work the same way?
Yeah, on mine it does.
Okay. Cool. Awkward. So I tried to paste the bar graph in, and it changed number 8 to be number 12?
Huh. Odd.
Okay, so 5 descriptors. Sorry, 5 descriptors could be um oh, is there a we have mean, standard deviation, um, I don't know, there's a ton of stuff we could give them. Could give them the confidence interval, we could
Okay.
5-number summary.
Yeah.
That's plenty of descriptives. Or the variance.
7% is the true unknown percent of the population do not have traditional phones, instead rely on cell phones. Suppose a random sample of 750 telephone users is obtained. What is the probability that more than 60 phone users, 8% in this survey, use only cell phones? What is the mean and standard deviation of the sampling distribution based on 750 telephone users? Okay.
So, our mean is going to be the 7%. Is that
right?
Huh?
Right.
Okay. I just wanted to make sure that I understood the reading right, because it was, I don't know, I felt like it was kind of confusing.
What is the mean and the standard deviation?
So our mean would be 0.07?
Correct. 7%.
Then my calculator real fast.
So we have the square root of p times 1 minus p divided by n, right?
Yep. Square root of p, which is 0.07, times by 1 minus 0.07.
Yes.
That is a small number.
Point zero zero
9?
9. I got 0.0093166,518.
In here.
Oh, but they got 0.0099. So where did we get off?
I have no idea. With us being that close. Well, I don't know. Did you round it all in your when you were calculating it?
I didn't.
Me neither.
Should we have?
Maybe they did.
I don't know. That's an odd one. Because all the tests and stuff says don't round until the very end. That's kind of the rule I've taken on everything else, you know?
Uh-huh. Yeah, and that's what we should take, and we're only supposed to round to 3 decimal places too, right?
Let's see. Well, according to this, the mean is 7% or 0.07. And
Mm-hmm.
the standard deviation is 0.0099 is what it says.
I don't know. My thinking is we did it right. I think we're good.
Well,
Well,
but see if we keep going,
is that gonna mess up everything else too?
that's going to mess when we try to find our z-score. Because z-score, you have to have
The standard
standard
deviation.
deviation minus p over the square root of p, basically the same thing we just did.
Hmm.
Shoot. Let me move for a second. Okay. Let me try this one more way. Uh, I still get 0.00931666518. Huh. How do you figure they got this?
By not using 750 as a sample size? Because I just calculated it again using 690,
Yeah.
and it came out to be 0.0097.
Huh.
So that could be a contributing factor. Um, Let me try one more thing. One more idea. And it doesn't work. Yeah, I don't know. I would guess that they rounded sooner than they should have. That's the only thing I can think of.
Okay. The only way it works is if we go with a p of 0.08. Is that what we were supposed to do? Because we're going to test to see if we're going to test the 8%. If you use 0.08,
It
the
works.
probability of 8%, it works. Is that what we're supposed to do then?
I guess so. If it gives us exactly that answer, then yeah.
Because if we do 0.08, you get 0.0099062253.
Yeah, I guess so. I guess we are finding the standard deviation for our sample.
We're finding it for the idea that 8's going to be
I guess so.
So then, state the problem in terms of a variable. So we are uh, P.
Baby sunglasses.
We want to find out more than 8%, so we're going to go P over 60 over 750, or P is greater than 0.08, right?
Uh-huh.
Okay. And then we're going to use the probability applet.
Oh, the probability applet. It's my best friend.
Yay, probability applet.
So we're saying, sorry, we said greater than 0.08?
Right.
No, the p hat is greater than 0.08. Okay. So,
But we need to find the z-score. So,
1.405? Does that sound right?
let me do the math on this one. So we're going to go with,
Or maybe we're not supposed to use the applet there, and we're just supposed to say we have a normal curve, and we're going to be shading the right side. Because later on, they actually ask us to find the z-score.
right.
And
That's what we
very next
would.
question.
Yeah. I guess I had skipped the next question. I'm sorry.
No, you're good. The question makes no sense, so you're good.
So our z-score, we're going to go 0.07 or 0.08 minus 0.07.
And then we're going to do that over our standard deviation.
So point,
One
so
zero
it's
one zero
0.01 divided by 0.0099.
Did you get 1.01010101?
I did, and that's different than what they got again. Okay.
Curious.
They got 1.073. But if we do 0.08 minus 0.07 equals 0.01, right?
Uh-huh.
Divided by 0.0099. 101010101010. Okay, what am I missing here?
So remember how our first standard deviation was 0.00931166?
Yes.
We use that, we get a z-score of 1.073.
Okay. I'm going to have to figure out which one to use when. That's going to be tricky, it sounds like. Okay.
To be honest, I think it's just to make in the preparation assignment.
1.073.
I mean, the standard deviation should be the same between them.
Okay, so did you get a probability of 0.1416?
Yep.
Okay. So basically there's a 14% chance that more than 60 phone users in the survey only use cell phones.
Yep.
Okay, shall we try the test?
Let's do it. I am ready for this. I'm not. I'm mildly more confused than I was before, so hopefully it's nothing too crazy.
True.
Group meeting.
Okay.
Starting.
Okay.
I love question 3.
Yes. I hope you got B.
I don't know. Pie charts are more visually appealing when the slices are different sizes.
That sounds good. The size of each slice is determined by the number of categories.
Sure, I think the size of each slice is random. Oh, man. Great questions. How are bar charts and Pareto charts related? The only difference is that one is organized largest to smallest, right?
Right.
Okay. We conclude the p-hat is normally distributed if n times p is greater than or equal to 10, and n multiplied by 1 minus p is greater than or equal to 10.
P is the true proportion in that, right? Because P with the little thing over it is the sample proportion.
That's my understanding, yeah. What is n? Sample? Or no, the number of candidates in an election. Maybe? I don't know. Or the sample size. I think it's the sample size.
So on 5, you got true proportion, right? I'm just making sure.
Yeah.
Okay. So 7 has to be 20, right? No, 40.
How would it be 20?
I mean 40.
I must have I don't remember going over this. How would it...
Okay. NP has to be greater than or equal to 10, right?
Oh, yes.
So if P equals 1/4, the smallest n that satisfies the requirements 40, correct?
Oh...
Okay.
It would be 3.
On
I don't
8?
know. Hear me out, because n multiplied... Oh, wait. Just kidding. Yeah, you're right. It's 40.
Okay.
Had to think about it for a second.
Because otherwise you would have, let's see, 40.
Because... No, you're 100% right.
Okay. I hope.
I hope... Well, I mean... 40 multiplied by 1/4 is 10, so... But... 40 times a negative 1/4 would be negative 10.
Okay. I'm going with 40 and moving on because I
Okay, sounds good.
n times p has to be equal to or greater than 10. So the smallest to me, because we're still satisfying the second one, because n times 1 minus p would be 30. So we're still greater than 10. So yeah, I think it's got to be 40.
Okay. Alright, so use the following information to answer questions 8 and 9. Suppose that n is 24 and p is 0.4. Well, what is the mean of p? We would say 0.4, right?
Yes.
Okay.
I think. Let me look. Okay. Yeah, we'll go with 0.4.
And then let me know when you've gotten the standard deviation, because I have found it. Or at least I think I found it.
Uh, 0.1?
That's what I got.
Okay.
Brittany's batting average is 0.3. We want to determine the probability she will get more than 35 hits in her next 100 bats. At bats. Bats? At bats? It's a lot of bats.
So P is 0.3?
0.3.
Yeah, 0.3.
Yeah.
Standard deviation.
Point 0.046.
Yep.
Okay. So our Z score.
Second. Can you hold on just a second?
Yeah, not a problem.
We are unable to come to the phone.
Hello. Good. I'm right in the middle of a class. Can I call you right back? Okay, I'll try about 5 to 9 minutes.
Okay.
Okay. Right. Thank you. So, okay. Did you get 1.11111111
For what?
for the z-score?
No, I did not. I got 1.087.
Okay.
Let me make sure I did it right, though. We wanted to do 0.35 minus 0.3 divided by our standard deviation of 0.046, right?
Right.
Okay.
Oh, okay. I just redid it. I got 1.087.
Yeah.
Okay. Okay. So then we go to our applet. I got 0.139.
Same here.
Okay, you got to stop that. uh,
Okay, so if the true population of people who support political candidate is 0.52, and if 2,000 people are surveyed, we want to determine the probability. The survey will suggest that the candidate is losing the election.
yes. So we have to go through, find our z-score, and then find below it, right? So,
Just to find the standard deviation?
well, we want the. Oh, okay. So we just want standard deviation here. Okay.
Yeah, first standard deviation, then z-score.
So we're at. Okay. We have what, 2,000?
.011.
Okay, let me try that one more time.
What did you get?
0.52 times 1 minus 1.52 divided by 2,000. 8. I got 0.004.
Okay, so I did 0.52 times 1 minus 0.52 divided by 2,000, and then took the square root of that.
Right, that's what I did. Let me try it one more time. Okay.
0.52 times 1 minus 0.52.
Okay, so then that's 0.2496 divided by 2,000 is 0.001248. Square root 0.001248 is 0.011. Yep, you were
Okay.
right.
So then for a z-score, we do 0.5 minus 0.52 over our standard deviation. Is that
No, we're going to do 0.52 minus 0.5.
how come?
Because our P, which is what our population was, is 0.5, and what we're trying to find out is the probability that. No, you're right. It's 50 minus 52. I'm sorry.
No, you're good. But we would do that because because p hat is what we want. I don't know how to explain it.
Yeah. Did you get negative 0.1818181818?
Yeah.
So we're just going to do negative 0.182.
Negative. Sorry, I got negative 1.818181.
Okay.
So it was
0.50 minus 0.52.
is a negative 0.02, right?
Right.
And then divide that by 0.011.
Negative 1 point.
Okay. 1.818.
Okay. Okay.
I don't understand what 16 is asking.
Yeah, that's why I'm kind of looking back at the thing. Uh, okay, dude, I would say, because what are we figuring now? We're figuring the big Z is what we're figuring, and little Z is for 52, right?
I don't know. I feel like it would be the other way around, but how do we know?
Okay, well,
Let me Google it. Maybe Google will tell us something about big Z's and... nope. Tells me nothing. Okay.
okay, 0.035 for our probability.
Mm-hmm.
Okay, we'll go with that. And basically flip a coin on 16.
I'm gonna say the second one.
Second one? Okay, I'll go with you.
Just because we're taking the very left side of this one. Is that right? I don't know, but...
Ooh, what did we miss? Well, we missed 10. We missed 15.
Wait, we missed 10, but we still got the rest of that right?
I guess it says we missed 10 and 15.
Oh, okay, so 10, it was p hat, which should have been 0.35.
Oh, yes. That's correct.
And I don't know about 15. The only thing I can think is that it's a positive 1.818.
Could be. Alrighty. Let me get on here.